Hi friends, in the last video we learned that the work power energy where we learned the units of power just up to this. Again we are going to learn and start today about the units of power from this, that is units of power. In the last video, in the previous class, we learned what is power, what is the relation between power, force and velocity. Now we are going to learn the units of power again. In SI unit, the unit of power will be work done by time. That is, the unit of work done is joule divided by second. This is called watt. This is called watt. And in CGS unit, what happened? In CGS unit, the CGS unit of work done is arc divided by second. Similarly, in FPS unit, that will be the unit of work done poundal foot divided by second, poundal foot per second. Now, another one unit is used to measure the power of a mechanical device or any other devices like the electrical devices also, like electric motor. Here we use the term HP, horsepower. Another one important unit is horsepower. Horsepower is a large unit of power. This is the practical unit of power. And 1 horsepower, very important relation. 1 horsepower, this is equal 746 watt. 746 watt. And we can define this 1 horsepower. This is equal, if a body of mass 550 pound is raised through a height 1 foot against the gravity in 1 second, then the power of it is said to be 1 HP. That means 550 foot poundal per second. This is equal 746 watt. Okay. Now another one part of it, that is how can you get the different forms of energy. What is energy? Energy is the capacity or ability to do work. Energy is the capacity or ability to do work. This energy may be of different forms in different kinds. If we consider in this chapter, there are two parts in the dynamics and also in the statics, including both of them. They are the potential energy and the kinetic energy. Before going to this potential energy and kinetic energy and the mathematical form of this potential energy and the kinetic energy, now we learn first the dimension of it. The dimension. The dimension of the energy will be the dimension of the work done. That is ml square t to the power minus 2. ml square t to the power minus 2. This is the dimension of energy, and the units of energy is the joule. SI unit joule, that is the similarly the units of the work done. And this energy here may be of different types on the basis of this, that is either the body is in motion or at rest, that is potential energy for the body is at rest, simply denoted by PE. And another one, that is kinetic energy if the body is in motion. If the body is in motion, simply we write this KE, kinetic energy. And now we are going to learn about the mathematical derivation and how can you define this potential energy and the kinetic energy. In case of the potential energy, when a body, now consider this is the body, now this is here. If we changes the position of it on a plane, then some amount of work has to be done, and this amount of work is stored within this body as the potential energy. Now we can consider this, we can calculate also here. the potential energy, the mathematical form of it, that is very well known to us, that is PE equal potential energy, this is equal mgh, where let us consider this is the ground surface. Now a body is raised through a height h from the ground AB. Now the body is raised to a certain height at the position D, that is the height from the ground B h, the height B h. Then what happened? Then some amount of work is done. That is the weight of the body W, that is equal mg. If m be the mass of the body, then the weight of the body W equal mg, and now the body is raised to a certain height h. Therefore, work done on raising the body from AB plane to the D, the work done will be work done. This is equal the force into displacement. Force into displacement. Here the force is the W equal mg and the displacement is h. This is equal mgh. This amount of work done is stored within the body as the potential energy when the body is at rest. When the body is at rest, the mathematical form of the potential energy, that will be mgh. But what happens in case of a body in motion? When a body is in motion, the amount of work done will be its kinetic energy. That is the amount of work has to be done to move the body either from rest or to accelerate the body or to retard the body. So that means we have to produce the motion within a body. Either the body is at rest, then the body starts to move, or if the body is in motion, then when we push the body, then the body will accelerate. If the force is applied in the same direction, if it is applied in the opposite direction, the body will return, then some amount of work has to be done. Then this work is stored within the body as the potential energy. Let us consider here. Let us this is be the plane AB, this is with the plane AB. Now the body is here, the mass of the body be m. Now the body is at rest, u equal 0, that means the body is at rest. Now it is forced or pushed towards this direction by a force capital F, and finally after traveling a some distance s, when the body is here, then the velocity of the body becomes v. So this is the distance as well as the displacement also from the point P to the point Q. Now the position of the body is here. So how much amount of work is said to be done? Let us consider work done by the moving body. Work done by the moving body. Work done by the moving body. This is equal also force into displacement D. That is the force. This is equal according to Newton's second law of motion, m into a into displacement. Here the displacement is pq. Pq, this is equal s. Since the displacement pq equal s. So the result will be m into a into s, where a is the acceleration. As the body is forced or pushed in this direction, that's why the work done will be m into a, where a is the acceleration. In another one relation, we use the relation v square equal u square plus 2as, where the relation stands for the body, where the body suffer a distance or displacement and the velocity of the body changes with respect to this displacement. Now the velocity of the body becomes v, and the initial velocity, that is 0, of initially the body is at rest, u equal 0 plus 2as. Here also the displacement is denoted by the small s. Therefore, we can write v square equal 2as, or simply as equal v square by 2. Now substitute the value of this as by v square by 2. Then we get, that is m into v square by 2. This is equal half m v square. Okay, this is the work done by the moving body. This amount of work done by the moving body will be consider as the kinetic energy, store within the moving body as the kinetic energy, and by using this method we can get the relation kinetic energy of a body. This is equal half mv square. Kinetic energy equal half mv square for a moving body. So this is the relation, the kinetic energy, so that the relation kinetic energy equal half mv square. If we consider the body is initially moving at the velocity u, the relation becomes half mu square. These are very important concept. Another one important concept is here, the total amount of energy remain constant before reaction, after reaction, before change, after change. Only it transforms from one form to another. That is called the law of conservation of energy. In the next video, we also learn in case of the free fall body, mechanical energy is conserved. Together, the potential and kinetic energy together is called the mechanical energy, that is ME. Today up to this. Okay.